Hello my dear friends, how are you all? I hope you all are fine. So you are very welcome in a lecture number 3 of areas of parallelograms and triangles. Okay, so my dear friends, I hope you will enjoy this lecture. So let's start without wasting the time. Okay, so now here is today we are going to discuss, yes, parallelograms on the same base and between the same parallels. Okay, yes, so now here is two parallelograms are said to be on the common or same base and between the same parallels if there are two conditions. What are these? They have a common side, okay, and the second is the sides parallel to the common side lie on the same straight line, okay, lie on the same straight line. So here is you can see in the diagram, okay. So now in the diagram here is A, B, C, D. There are two figures. And the second one is A, B, E, and F. Okay. So these two figures are what? They are parallelograms on the same base. Same base is what? AB. Okay, so A, B, C, D. Okay, and here is A, B, C, D. And A, B, E, F. So they are on the same base. They lie on the, yes, same base. Okay, and they have a common side, and the sides are parallel to the common side lie on the same straight line. Means here is, we know that DC and DE FE. Okay, so these sides parallel to the common sides, which is AB. Okay, DC is parallel to AB, we know that, and FE is parallel to AB because ABEF is what? This is the parallelogram. So my dear friends, I hope you understand these things. Yes, so now let's see the theorems based on these topics. Okay, so now here is, now the theorem 9.1 is parallelograms on the same base and between the same parallels are equal in area. Are equal in area. Yes, so now we have parallelograms. Okay, we have two parallelograms which are on the same base and between the same parallels. Okay, like here you can see that A, B, C, and D. This is the first parallelogram. Okay, and the second parallelogram is E, F, C, and D. Okay, so these are the two parallelograms which are on the same base and between the same parallel line. And we have to prove that the area of these two parallelograms are equal. Okay, so first of all, here is, we have to write the given part. Okay, so what is this? So here we have two parallelogram A, B, C, D and E, F, C, D. Okay, now that have the same base, here is, we can write same base is what? Same base is CD. Okay, and they lie between the same parallels. Okay, so we can write same parallels which are AF and CD. Okay, I hope you get this point. And here is, we have to prove we can write it as area of ABCD is equals to area of EFCD. Got it? So we have to prove the area of parallelogram ABCD is equals to area of parallelogram EFCD. What is? Yes, EFCD. I hope, my dear friend, you understand these things. Okay. Yeah. So now let's start. So here is proof. So here is, we know that opposite sides of parallelograms are parallel. Okay. Opposite sides of parallelogram are parallel. What is? Yes. Okay. So here is, we have two parallelograms A, B, C, D and E, F, C, D. Okay. So now when we know that AD is parallel to BC, because here is this line AD is parallel to BC, because these are what? These are the opposite sides of parallelogram ABCD. Okay, with transversal. Here is with transversal AB. Here you can see this is the transversal AB. Okay, I hope you get this point. So now here is this angle, angle A, and this angle. They are the interior angles, and here is angle A and angle EBC. This angle. This is corresponding angle. This is what? Corresponding angle. So we can write here as angle DAB is equals to angle CBF. This angle CBF. This. Okay. So because they are the corresponding angles. Corresponding angles. Let's suppose this is equation number 1. Now if we are taking ED is parallel to FC. ED is parallel to means this line, this ED, and parallel to this FC. Okay, here is, because we know that these are the these are the opposite sides of the parallelogram EFCD. Okay, so here is this angle DEA, okay, is equals to this angle CFB, because corresponding angles. Okay, so we can write here as, and here we are taking the transversal is EF. So here is transversal is EF. Okay, so we can write with transversal EF. So angle DEA is equals to angle CF. This angle CF, we can write this angle CFE. Okay, this angle is also called angle CFE. So angle CFE. Okay, because this is corresponding angle. This is what? Corresponding angles. Now let's suppose this is equation number 2. Okay, also here is, we can write also AD. This AD is equals to BC, because we know that opposite sides of parallelograms are also equal. So AD is equals to BC. No, opposite sides of parallelogram are equal. Now my dear friends, here is, now in triangle AED means triangle 1, and in triangle BFC means this triangle. In these two triangles, if you see that here is This angle is equals to this angle from equation number 1. This angle is equals to this angle, okay, from equation number 2. And AD is equals to BC from equation number 3. Let's suppose this is equation number 3. Okay, so we can say that these two triangles are congruent. These two triangles are congruent by what? By angle side rule. By angle side rule. Got it? So now here is we can say that these two triangles are congruent by angle side rule. Okay, so now in triangle AED and triangle BFC. So angle DEA means this angle is equals to angle CFE means this angle and is equals to angle CFE. Okay, so we can write from equation 2nd. Okay, and angle DAB means this angle is equals to angle, here is, okay, angle CBF. Okay, this angle DAB and angle CBF, this angle. So they are equal. We can write from equation number 1. Okay, and here is we know that AD is equals to BC. We can write again from equation number 3rd. Got it? Yeah, so we can write here as triangle AED is congruent to triangle BFC. So they are congruent by what? By angle side rule. Angle side rule. Okay, my dear friends, I hope you understand these things. Yes. So now we know that these two triangles, triangle 1 and triangle 2, are congruent. It means the area of these two triangles are also congruent. So hence we can write area of triangle AED is equals to area of triangle BFC. Okay, so areas of congruent figures are always equals. Okay, yes. Okay, so now my dear friends, here is we can write area of ABCD. Okay, area of ABCD, which is equals to, here is we know that we can write it as area of triangle AED, area of triangle AED plus area of EBCD. Okay, we can write it as, because here is we know that area of ABCD is the combination of this triangle and quadrilateral EBCD. Okay, this quadrilateral. Okay, so we can write it as also. Now here is we know that this area of triangle AED is equals to area of triangle BFC. We already proved this. Okay, so here is we can write area of triangle BFC in place of area of triangle AED plus, and this is as it is, so this is area of EBCD. Now if we add EBCD, area of EBCD plus area of BFC, then we get area of EFCB. Okay, then we get area of EFCD. So this is equals to area of ABCD. So my dear friends, here is we can say that hence proof. We can say hence proof. This condition we have to prove this. Okay, so this is what we can say, that if two parallelograms are on the same base and between the same parallels, then we can say that the area of these two parallelograms are always equals. Okay, so I hope you understand these things. So now let's move on. Now let's solve some problems. Okay. So now here is in figure ABCD is a parallelogram. Here is A, B, C and D. This is what? This is parallelogram. AE is perpendicular to DC. Here is this AE is perpendicular to DC and CF is perpendicular to AD, means this CF is perpendicular to AD. If AB is equals to 16 centimeter, okay, and AE is equals to 8 centimeter, okay, and CF is 10 centimeter. Now find AD. Now we have to find AD. Okay. Yes. So now my dear friends, here is we know that area of parallelogram. Area of parallelogram is equals to base into height. Base into height or altitude. Okay. I hope you understand these things. Now, for parallelogram A, B, C, D, here is when AE is perpendicular to DC. AE is what? Is perpendicular to DC. Okay. Now in this case, here is we can write AE is the height. AE is the height. Okay. And DC is the base. DC is what? DC is the base. Okay. So the area of parallelogram ABCD is equals to what? This is equals to, we know that base into height. So base is what? DC into height is what? Height is AE. Now here is we know that AB is 16 centimeter, means this side. So DC is also 16 centimeter because we know that opposite sides in a parallelogram are equal. We know that opposite sides of a parallelograms are equal. So here is we can write it as AB is equals to DC, which is equals to 16 centimeter. Okay. So from this we can write it as DC is what? 16. Now AE it is given in the equation which is 8. So from this we can find the area of parallelogram ABCD. So this is 128 centimeter square. What is 128 centimeter square? Let's suppose this is equation number 1. This is equation number 1. Now here is, now again, for parallelogram ABCD. Here is, now in this case we are taking, we know that CF is perpendicular to AD. CF is perpendicular to AD. So in this case CF is height. CF is the height and AD is base. Now in this case we are changing the base and height, but the area should be same. Area should be same in both the cases. So here is, we can write again, area of parallelogram ABCD. Area of parallelogram ABCD. Okay. Here is, we know that this is what? Base into height. So what is base in this case? So we know that base is AD. But we don't know the value of AD. Into height is CF, and the CF is what? CF is 10 centimeter. So we can write CF is what? 10. Okay. So let's suppose this is equation number 2. So now from 1 and 2, we know that area of these two conditions are equal. So here is, we can say that, okay, so here is, we know that this is what? This is 128 centimeter square. So we can write 128 is equals to AD into 10. AD into 10. Okay. So from this, AD is equals to 128 divided by 10. Okay, so after solving this, we get 12.8 centimeter. So here is AD is what? 12.8 centimeter. So I hope, my dear friends, you understand these things, how to solve these types of questions. Okay. The next question is, now question number 3 is, P and Q are any 2 points lying on the sides DC and AD respectively of a parallelogram ABCD. Okay, so we have a parallelogram ABCD, and P point lie on DC and Q point lie on AD. Okay, now we have to prove that area of triangle APB, which is equals to area of triangle BQC. Got it? Yes. So now here is, so we have the given part, which is parallelogram. We have a parallelogram ABCD. Okay, and here is P and Q are any points on DC and AD respectively. Okay, yes. So now, and we have to prove, area of triangle APB, which is equals to area of triangle BQC. Okay, we have to prove this. Yes, so now let's start to prove this question. So here is, we know that ABCD is a parallelogram, so we can write here as, so AB is parallel to DC and AD is parallel to BC, because opposite sides of a parallelogram are equal. Okay, so triangle APB, this triangle APB and parallelogram ABCD lie on the same base and are between the same parallel lines AB and DC. AB and DC. So we can say that area of triangle APB is equals to half of the area of parallelogram ABCD. Okay, so we can say that here is, they lie on the same base. They lie on the same base AB and between the same parallels, which is AB and DC. Okay, so similarly we can say that again, here is similarly triangle QBC and parallelogram ABC again lie on the same base, which is BC, and between the same parallels AD and BC. So again we can write area of triangle QBC is equals to half of the area of parallelogram ABCD. Okay, again they are on the same base, which is what? Same base is BC. Okay, and same parallel, between the same parallel. Same parallel is what? Same parallel is AD and BC. Okay, I hope you get this point. So now from this, now let's suppose this is equation number 1 and this is equation number 2. Okay, so we can write from 1 and 2. So from 1 and 2 we can say that area of triangle APB is equals to area of triangle QBC. Okay, I hope you get this point. So we can write hence proof. Okay, because here is area of triangle APB is equals to half of the area of parallelogram ABCD. Similarly, area of triangle QBC is equals to half of the area of parallelogram ABCD. So we can say that the area of these two triangles are equal. So my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.